This is chapter 4-7, solving polynomial equations. So we kind of ask the question, well, why are we turning these expressions something like, why are we turning the expression x squared plus 5x minus 6? Why do we turn that expression into the product of two binomials? What's the reason behind that? Why is this expression better than this expression? Well, some of you will notice automatically why the bottom one is better. We have a variable x, and it's to the same degree. And then in our numerator, in the other expression, we have x to the second and x to the first. So that makes it harder to isolate. We can't isolate those. This we can kind of isolate. In fact, we're going to use, the reason why we start with the expression is we learn how to turn an addition and subtraction problem into a multiplication. Why multiplication? Well, because when we set it equal to 0 when it's an equation, again, we can't isolate. You can't isolate for x because there's an x squared. When we look at this, now we can't isolate it, but we know that the product, that's not how you spell product, of two unknowns that equals 0, one of these must be 0. One must be 0. So that's the only way you can get 0 through multiplying. No other number produces that. So that's why we like turning it from addition and subtraction to multiplication. Now we start off here, and so either this box needs to be 0 or this box needs to be 0. And so what we do is we ask the question, okay, what value for x when it's x minus 2 will make it 0? So what value will make it 0? So we add 2 and we get x equals 2. When x equals 2, this binomial, this value inside the parentheses becomes 0, which would make the product 0. And then we split it to the other one to ask, okay, what value for x would make this binomial 0? Well, when x equals -4, that will make it 0. And you say, well, you can't have both of them. No, it's one or the other. And the way we check it, you can check it. We'll do this just for this one. If we check, so let's look. Let's put 2 in for x. Does it make it true? Well, 2 minus 2 is 0. 2 plus 4 is 6. 0 times 6 is 0. Yes, so that is a solution. Let's check the other value. 4 minus 2 times 4, sorry, -4. -4 plus 4. That gives us -6. That gives us 0. -6 times 0 is 0. That's a solution. Those are the only two solutions. Let's use a different number. Let's check with some other value. Let's check with 3. What if we have 3 minus 2 and 3 plus 4? Well, that's 1. That's 7. And 7 doesn't equal 0. So we know that 3 is not a solution. So the only ones that can make one of those 0 would be -4 and 2. So we would write our solutions in a solution set, and those are our values. So we're going to do it real fast here. We can, in fact, right, this is mental math here. We don't even have to write this out. We should be able to look at that and see what our zeros are. -3 minus 4 minus 4, t equals -4. So my solutions are -4, -3. So in these first sections, now we get a little bit, and I would tell you anytime your coefficient is more than 1, I would definitely write it out just to ensure so you don't make any silly mistakes. Y equals -3/2 and plus 3, y equals 3. So -3/2, 3. We're going to set each one equal to 0. Minus 1 equals 0. Plus 1 plus 1. 3k equals 1 divided by 3. K equals 1/3. Plus 1 plus 1. 2k equals 1 divided by 2. K equals 1/2. So my solution in numerical order is going to be 1/3, 1/2. And as we know, so what if we have 3 binomials? Well, again, all 3 of those are multiplying each other. So as long as they're multiplying, we know that one of them must be 0. That's the only way you can get 0. Inverses, negatives don't make 0. The only thing is one of them must be 0. So you, again, set each one and ask, when you set it equal to 0, you're asking what value for x makes that little portion 0. So -5 would make it, is one of the solutions that would make it 0. X equals -1 would be another one. And x equaling 8 is the third one. So we could actually have 3 zeros. And these are also going to be known as x-intercepts. This constant out there, that's not a constant, the variable outside, that's multiplying. So we say r equals 0, r plus 2 equals 0, and r minus 1 equals 0. Minus 2 plus 1, and this is a solution. So we have -2, 0, and 1. That's a good one. All right, so now how do we add complexity to it? Well, you're going to have to factor. So we're going to do, now we remember our A is 1. We should be able to look at this and find factors of 27 when subtracted, and the signs are different. And the bigger is positive, that equals 6. But we'll go through it. It's A times C. We can use A times C. And let's go over the steps. Step number 1 is always, is it equal to 0? Set equal to 0. Yes. Then, is it in standard form? Is it x squared, x, and then your constant? Yes. Is there a common factor on the left? Can we factor the left side? Nope. Is it a special case? Is it a binomial square, or is it the difference of squares? So binomial square, second sign is negative, so that's no. And then we're going to do A times C. So A is 1, C is 27, equals 27. Factors of 27 are 1 and 27, 2 no, 3 yes, 3 and 9, 4 no, 5 no, 6 no, 7 no, 8 no, 9. Good. So my signs are different, and the bigger is positive. So the bigger of the 2 factor pairs, that gives me 26. That gives me 6. Which one of those equals my middle? Is 6. That's my middle. So I'm going to use these 2 numbers, and I'm going to break that into 4 terms. I'm going to take this positive 6x, and I'm going to use negative 3x and positive 9x, which does simplify to 6x. And then I'm going to bring down my negative 27 equals 0. Now we're going to factor by grouping. I'm going to group the first 2 and the second 2. We can factor out an x. You get x minus 3. We're going to factor out a 9. We get x minus 3. I know I did it right because those in the parentheses are the same. I'm going to pull that out, and what are we left with? X plus 9 equals 0. So that's all the problems that we've been doing prior to that. So we know that we have the product of two terms, which equals 0. So I'm going to set each one equal to 0 to see what value of x would make that binomial 0. So add 3. So x equals 3 would make one of those two binomials 0. Minus 9. X equals negative 9 would be the other term. So we have negative 9, 3. This one, so set equal to 0, yes. Standard form, yes. Common factor, no. Special case, binomial square, no, that's 3 terms. Difference of squares, yes. Just 2 terms, subtraction, and both are perfect squares. So that is going to create conjugates. Y minus 3, y plus 3 equals 0. Set equal to each equal to 0. And we get y equals 3, y equals negative 3. So we can write it 2 different ways. You can write it the 8th grade way, or you can write it plus or minus 3. That's the high school way. You're going to see more high school students. So remember what step 1 is, set equal to 0. We want to take advantage of it being of a product equaling 0. So we're going to add 4t. So t squared plus 4t equals 0. Okay, now, is it in standard form? Yes, t squared then t. Is there a common factor? Yes, there is a common factor, t. So we take it out, t plus 4 equals 0. We now have the product of 2 things that equals 0. We're going to set each of those equal to 0. T equals 0 is already isolated, minus 4, t equals negative 4. So my answer is negative 4 comma 0. Those are the 2 solutions for that problem. We're going to isolate and set it equal to 0. So we'll move that 35z over. We get 5z squared minus 35z equals 0. We see a common factor of 5z. That gives us z minus 7 equals 0. Set each one equal to 0. 5z equals 0. Z minus 7 equals 0. Divide by 5. Z equals 0. Add 7. And we get z equals 7. My solution is 0 and 7. We could be checking identify all double roots. Okay, well, roots are still zeros. When they say roots, we're talking about the 0. We're looking for the x-intercepts. When x-intercepts, we know that y is equal to 0, so we utilize that. That's y. That's the reason behind it. This, hopefully, you see is a binomial square. So square root of x squared is x, square root of 25 is 5. We're going to pull down that sign, quantity squared, because this is twice the square root of x squared times the square root of 25. That equals 0. Now, we understand that that is this when we see that. So it's still the product of 2 numbers. We could rewrite it, each one, which is kind of redundant and silly. But you get x is 5 and x is 5. You don't have to write 5 twice. You just write the solution. X is 5. That's your answer. Subtract 14, subtract 14. N squared minus 5n minus 14 equals 0. It's in standard, it's set equal to 0. It's in standard form. There's no common factor. It's not a special case. So we'll do a times c, 1 times 14, 1 and 14, 2 and 7. Signs are different. And the bigger is negative, so negative, negative, positive, positive, because the signs are different. Negative 13, negative 5. My middle is equal to negative 5. I'm going to use these two to change my trinomial to a polynomial. Plus 2n minus 7n minus 14 equals 0. We're going to factor by grouping the 2 and group 2. Whenever you have 4 terms, you should always be trying to factor by grouping. We can factor out an n. We can factor out a negative 7. First term is negative, so that's why we factored out a negative. You must whenever your first term is negative. So we know we did it correctly because you have n plus 2 in both of those parentheses multiplying. So we can factor it out and you get n minus 7. Set each one equal to 0. N plus 2 equals 0. N minus 7 equals 0. Subtract 2. N equals negative 2. Plus 7. N equals 7. Minus 2, 7 are your solutions. Oh, okay. So a lot of students would want to minus 6p squared, but you get negative 6p squared plus p plus 1 equals 0. And we can't have a first term negative when factoring. So we could do two things. We could have, when you had this equation, you could have minus p and minus 1. And gotten 0 equals 6p squared minus p minus 1. Now your first term is positive. Or we can factor out a negative, which gives us 6p. So there's a 1 there. 6p squared minus p minus 1 equals 0. A little bit the same, a little bit different. So we're still going to factor 6p minus 1. My a times c. My a is 6, my c is 1. 6 factors of 6 are 1 and 6, 2 and 3. Signs are different. And the bigger is negative. Positive goes there. Negative 5, negative 1. That's my middle. So we have 2 and 3. So you have negative 1 out here. 6p squared plus 2p minus 3p minus 1 equals 0. You're going to factor by grouping. And you have negative 1. So we'll factor out a 2p. You get 3p plus 1. We're going to factor out a negative, just a negative 1. Well, that's a tricky one. And you get 3p plus 1 equals 0. So we have negative 1 times 3p plus 1 times 2p minus 1 equals 0. Now we have 3 things multiplying to get 0. Negative 1. Well, that's a constant, so it will never equal 0. So we just write that statement. That can't be changed. It's sort of like when you see 3 times x, or times y, equals 0. My 0 is going to come from one of these two. One of those has to be the 0. That's not going to make it 0, but you can still have a constant and still get 0. It just means that it needs to come from one of those two boxes. So this 0 is not going to come from here because that's not going to change. There's no variable there. So we set each of these variables equal to 0. So that's where that negative didn't really hurt me. Divide by 3. P equals negative 1/3 plus 1. 2p equals 1 divided by 2. P equals 1/2. So my solutions are negative 1/3, 1/2. That negative 1 is not a solution. That's just what we're multiplying it by. So don't include that as a solution. It's not a solution. It's not a dual. Let's subtract 7, that's an ugly 7. Let's rewrite those 7s. 3s squared plus 20s minus 7 equals 0. Common factor, no. A times c, 3 and 7 equals 21. 1 and 21, 2, no. 3 and 7, signs are different because that's a negative. Bigger is positive. That's going to give us 20. That's going to give us 4. So this is my middle, 20. You see the 20 there. So I'm going to take these two values, -1 and 21, and I'm going to break that 20s, and I'm going to rewrite it as -s plus 21s. We combine that, it takes us back to 20s. So I haven't changed it, I've just unsimplified it. Oh, I like that. I've never used that term. So now we're going to factor by grouping. You're going to take out an s, you get 3s minus 1. We're going to take out a 7, and you get 3s minus 1 equals 0. 3s minus 1, s plus 7 equals 0. Product of 0. Set each one equal to 0, and then solve for the variable. Add 1, divide by 3, s equals 1/3, minus 7, s equals -7. My solutions are -7 and 1/3. We're going to move the 13x over and the 10 over to the left side, which sets it equal to 0. We're left with 4x squared minus 13x plus 10. No common factor, so we'll do a times c. 4 times 10 is 40. Factors of 40, 1 and 40, 2 and 20, 3 no, 4 and 10, 5 and 8, 6, 7, no. And you'll notice that I do my factor pairs in numerical order so I don't forget any. And I always put the smaller on the left, larger on the right, so when I have to do signs are the same or signs are different. So that tells me signs are same and they're both negative. But if you don't put it in that order, when we do this one, you see this when the signs are different, and we know that the bigger is going to get the positive, I know that's going to go down my entire right side because all my bigger factors are on the right and all my smaller factors are on the left. So little teeny thing for you to consider or to pay attention to. That's the attention to details. And this is equal to my middle, -5, so 4x squared minus 5x minus 8x plus 10 equals 0. Factor out an x, 4x minus 5. First term negative, so let's factor out a -2. We get 4x minus 5 equals 0. Factor out the -4x minus 5, which leaves us with x minus 2. Product of two terms equaling 0, or two binomials. Set each one equal to 0 to find out what would make that box, that binomial 0. 4x equals 5, divided by 4. X equals 5/4. We don't have to turn it to a mixed number. In high school, we embrace mixed numbers, or excuse me, we embrace improper fractions. And let's put it in numerical order. We should know that 5/4 is smaller than 2. I'm going to move everything to the right. We get 0 equals 4x squared minus 4x plus 1. We should notice that that is a binomial square. If we do enough of these, you're going to recognize binomial squares and you're going to recognize difference of squares. It's imperative that you see the easy ones. This is easy. So square root, and bring down this sign, quantity squared. We have 2 of these equaling 0. So We just need to do one of them because it's going to give us the same answer. Let's be efficient and logical. So that's going to be my answer. I don't have to write it twice. Okay, no common factor. It's in standard form. It's not a special case. Let's do A times C. 5 and 6 is 30. 1 and 30, 2 and 15, 3 and 10, 4, no, 5 and 6. Signs are different. Bigger is positive. 29, 13, 7, 1. 13 is my middle. 5m squared minus 2m plus 15m minus 6 equals 0. We're going to only take out an m. That's all they have. We're going to take out a 3, and we get 5m minus 2 is 0. 5m minus 2, m plus 3 equals 0. Efficiency is always the name of the game. We want to be attacking when we see the problem. We want to recognize it and know exactly what we need to do. If you're going to be successful in any type of assessment, you need to recognize and have complete confidence in what you're doing. That you've done it so many times that you don't have to think about it. When you take a corner kick in a soccer game, you're not thinking about it. You just know what you're going to do. I see this. I know I have to set it equal to 0. I also know that I need to put it in standard form. So I'm going to do that while I'm rewriting this. I also have to recognize my first term is negative. That's a no-no. So we have to factor out a negative. No other common factor, so that gives us 12y squared minus 7y plus 1. Notice it changes all the signs of each of the three terms when I take a negative out of it. And now I'm going to look, it's not a special case, so I'm going to do A times C. 12 and 1 is 12. Factors of 12, I should be able to throw out those factors. Super easy. Signs are the same. Both are negative. And this is negative 7. That's my middle. I can just jump to that also. These are skills that will make you better. Minus 3y minus 4y plus 1 equals 0. We're going to factor by grouping. So we're going to factor out a 3y, and we get 4y minus 1. We're going to factor out a negative 1. We get 4y minus 1 equals 0. We have the negative out there. We have the 3y. Whoa. We have the 4y minus 1, which leaves us with 3y minus 1 equals 0. Negative 1 does not equal 0. 4y minus 1 equals 0. 3y minus 1 equals 0. Add 1. 4y equals 1. Divide by 4. Y equals 1/4. Plus 1 plus 1. 3y equals 1. Divide by 3. Y equals 1/3. Those are my two solutions. 1/4 is smaller than 1/3, Mr. Mac. And that's our answer. We are just moving along here. Ooh, I like this. Set equal to 0, good, standard form, common factor. We can take out actually t squared, which leaves us with t plus 4 equals 0. Product, technically you have three things because t squared is t times t, but you can still do that. Set each one equal to 0. If you want to be tricky, we're going to take the square root, and we still get t equals 0. Minus 4 minus 4, t equals negative 4. So my solutions are 0, negative 4, and 0. Let's move the 18z over. Let's move the 7z squared over. Minus 18z plus 7z squared. We get z cubed plus 7z squared minus 18z equals 0. We can't take anything but a z out. Z squared plus 7z minus 18 equals 0. Not a special case. 18 is not a perfect square. So we'll do a times c, 1 times 18, 1 and 18, 2 and 9, 3 and 6. Signs are different. Bigger is positive. 17, 7, 3, 7's my middle. Z squared minus 2z plus 9z minus 18 equals 0. Factor by grouping. I have my z on the outside, and then I'm going to factor out a z, and that leaves me with z minus 2. I'm going to factor out a 9. That leaves me with z minus 2 equals 0. So we have the z minus 2, and the z plus 9. We're going to set each one equal to 0. That's a horrible minus 2. Z plus 9. So z equals 0. Z equals 2. And z equals negative 9. So this is actually we knew it was quad 3. So we tend to end up with 3 zeros. Sometimes you don't because they're imaginary, or they're located somewhere else, or they're a different solution. But these are going to be the locations on the x-axis where there is a point or a solution, or the parabola, or whatever, the cubic is going to cross the x-axis, and it's up and down and stuff like that. So you see we have 1, 2, 3 intercepts. We would have 2 intercepts. Well, that's being squared. That's being cubed. 4 would go through 4 places. So that's what we're doing here. That's the reasoning behind it. Let's get this over. You get x cubed plus 12x squared plus 36x equals 0. Let's factor out an x. X squared plus 12x plus 36 equals 0. We should recognize it's a perfect square. Is it a binomial square? Yes, it is. Square root doubled. Does it equal my middle? Yes, it does. And is that positive? So it is. So this becomes that. And we should be able to do that super fast also. Or that fast, shall we say. So we have, x equals 0. We have x plus 6 equals 0. And we don't have to write it twice because we know it'll produce the same solution. So those are my 2. My 2. Now, that's an interesting thing. You should know that when it's squared, when it happens twice, that it's bouncing. It bounces off of, that's going to be 6. So that's what that's doing. When you get 2, negative 6. When you get a binomial square, what's happening is it's bouncing off of that intercept. Well, how can that be with 3 values? Well, you can have that. It bounces and then it crosses over 0. So that's what that looks like. It's going to look something similar to that. You see that? So it has an x-intercept of 0. That's 0 because it's on this is the y-axis. And then negative 6. So let's do something because we have time, and if you made it this far in the video, you're going to get a little bonus. So let's take this equation. Let's go to Desmos. Desmos, please don't make me wrong. X cubed plus 12x squared plus 36x equals, we'll do y. All right, so it just went the wrong way. Yes, hello. and that's end behavior. So we know since A is positive, we would be moving in this direction. So that was wrong. Mr. Mack's drawing has a negative A value. It would be going in a negative manner, left to right. And this is actually going positive. But notice it bounced off of that. That's why it has 2, and this is 1. Okay, so just a little important thing on what you're producing. Notice I said Y. If I did 0, you just get those. It doesn't come out as well because we want to see all of, and we're just looking for 1. Notice my Y is 0. My Y is 0. So when Y is equal to 0, it looks like this equation, Y equals 0. We just replaced it. Okay? Makes sense, hopefully. Leave page. Let's keep going. So I'm going to move this because that'll make it positive. And my largest term, my largest degree should be positive. So we get 2u cubed plus 15u squared minus 8u equals 0. We cannot factor out a coefficient, but we can factor out a variable. You get u, 2u squared plus 15u minus 8 equals 0. Not a binomial square because 8 is not a perfect square, nor is 2. So we'll do a times c. 2 times 8 is 16. 1 and 16, 2 and 8, 4 and 4. Signs are different. Bigger is positive. We get 15. That's my middle. So you have u out there. 2u squared minus u plus 16u minus 8 equals 0. Factor by grouping. You get u. We're going to factor out a u, which gives us 2u minus 1. We're going to factor out an 8, which gives us 2u minus 1 equals 0. We get the u, we have the 2u minus 1, and you have the u plus 8. U equals 0. 2u minus 1 equals 0. U plus 8 equals 0. That's isolated. Plus 1. Divide by 2. U equals 1/2. And minus 8. U equals negative 8. So my solutions are negative 8, 0, and 1/2. These are good. These are good. Oh, we still got a whole bunch left. Okay. Well, of course we have more left. So notice this isn't solved for 0. So we first have to multiply. You have to FOIL. So we get x squared minus 5x plus 6 equals 2. You should be able to multiply those two, first, outer, inner, last. You should be able to multiply binomials that fast, especially when your coefficient of x's are 1. And now we're going to minus the 2 over to set it equal to 0. And now we're going to factor. Yes, these are perfect squares, but this is not a binomial square because 2 times the square root of this times the square root of this does not give us 5. So not a binomial square, so we will do a times c. 1 times 4, which is 4. Factors of 4 are 1 and 4, 2 and 2. Signs are the same, and they're both negative. That's how we got our negative 5. That would have been our binomial square because of the same 2 factors. But this is my middle. So I'm going to, whoa, how did that happen? X to the 5th. X squared minus x minus 4x plus 4 equals 0. Factor out an x. Factor out a negative 4. X minus 1, x minus 4. Set them equal to 0. And we get x equals 1. X equals 4. 1 and 4. So let's multiply it out. X squared minus 4x minus 5 equals 7. Subtract 7 over. X squared minus 4x minus 12 equals 0. Factors of 12 when subtracted equal 4. When the signs are different, are x minus 6, x plus 2. Could you do it that fast? We should be able to look at those when a is 1. We should be able to look at the factors when subtracting equals that number. So can you get that good? Hopefully you are working. Instead of having to do a times c on these super easy ones, let's start pushing ourselves to doing mental math, to know it so well that we can figure it out mentally and save ourselves a little bit of time, 30 seconds. Whoa, ho, ho. So let's simplify. So that's negative 12a minus 4 equals 9a squared. We want our largest term to be positive. So we'll move those things to the right. Plus 12a plus 4. 0 equals 9a squared plus 12a plus 4. So I should recognize that's a perfect square. That's a perfect square. Does the square root of this times the square root of this doubled equal my middle value? Yes, it does. 3a times 4 times 2, excuse me, is 6a. Doubled is 12a. So I know that's going to be a binomial square. I don't have to write them both out. I know that I should just write 3a plus 2 equals 0. Minus 2, we get 3a minus 2, divide by 3, and we get a equals negative 2/3. Negative 2/3. Let's get it. Let's do it right. Oh, yes. Distribute out first. You get 5x squared plus 20x equals 18x plus 3. Let's move the factors or the terms over on this side because I have my 5x squared, which needs to be positive. So when you get really good, you can look at that and be able to find the factor pairs. 1 and 15, 3 and 5, signs are different. Bigger is positive. 2, we get 5x squared minus 3x plus 5x minus 3 equals 0. We'll factor out an x, 5x minus 3. We're going to factor out a 1. What? There's no common factor. So we always have to factor out a 1 if there's no common factor. That leaves us with 5x minus 3, which makes sense because these have to be the same. So let's pull the 5x minus 3, which leaves us with x plus 1 equals 0. Product of two binomials equaling 0. We set each one equal to 0. Plus 3. Divide by 5. X equals 3/5 minus 1. X equals negative 1. Negative 1. 3/5 are my solutions. Man, these are so fun. Oh, wowzers. Now, we could distribute, and we can look at it in that fashion, and we can go, oh, and then we can create this big thing and then factor it. But hey, folks, remember, we have the product of two things that equal 0. So this has to equal 0, or this has to equal 0. So why distribute? We've already done. So let's set that equal to 0. We know that what's the value there, and then we can't solve for it, right? Y squared minus 3y minus 10 would be our other statement, and we would factor that. And you have y minus 5y plus 2 equals 0, and then we set each of those. I like that problem. That would be a problem that you would save time if you recognize through your experience. Could you recognize what the proper way towards the solution is? Or are you just moving in wasted time. So we have -2 twice. We don't have to write it twice. So those are the two solutions. That's a really good problem. That's why I love this book. Oh, and it's the last problem. Yes, get good at this. Well worth your time and effort. Really important. You want to be a star in your math class? Know these problems inside out. Have a great day.